A very wonderful morning. Welcome to the program again. A segment of the program, very wonderful one here when we look at some things that are trending and making around here in the aviation sector. But we've been going through that, somewhat in the social media now. Everyone is talking about Nigerian Air, and some people say, look, we cannot wait. You can't commission something. We want to see the plane, want to see everything. We want to be on the ground. We want to hit the ground running and all of that. But somehow, it's just the way it is. My name is Iharuata. The program is This Morning on ITV. The segment is Aviation Update, and we will be doing that with your one and only aviation freaks here who have oftentimes dedicated this time to actually keep you fully informed. You know the biblical injunction here by Prophet Isaiah that the people perish for lack of knowledge. Sometimes you must acclimatize with your environment. Yeah, you cannot just be in the plane the way Atta would always do. I just get on the plane. As far as I'm concerned, the only business I got with that plane is let my boarding pass be ready first. Then I will go upstairs. I'm talking about the Abuja airport now. You rest here and you wait, and they call your flight, and you go down, you get the bus, you go into the plane, and when you're seated there, you make some call around, you rest, and when the plane is taking off, you wait for, let them serve me. I prefer somehow, just get those things. If I know I'm full, I collect them, I keep them. When I'm going there, I don't leave them in the plane. I take my thing away. So I take my thing away, I go sit down there, and I enjoy my time. Okay, Mr. Godike, that's nice there. Mr. Godwin Enike, that's the detail on the screen there, in case you want to interface with him here. Very open for us to discuss just with himself. And if you ask Mr. Godwin Enike, the details are all there. And let's quickly hit the ground running. A very wonderful morning, sir.
Hi, good morning.
Very wonderful morning, sir.
How are you, Atta?
Well, thank God the weekend was nice.
Yeah.
No, it wasn't too nice here. I know for sure we did some laundry in the house. On Friday, it wasn't dried. On Saturday, it wasn't dried. On Sunday, we got sunlight. The clothes got dried. This morning, again, we are seeing more of sunlight. And the kids are just at home here. They're going to tell you, hey, guys, take me out. I want to go for train ride. We want to go here. We want to go there and all of that. Everything they want you to cover. I said, look, I need to pay the bills.
Maybe you need to.
So I'm going, let madam take charge. They say, look, mommy is not always fond of taking us out.
maybe you need to save up some money to pick up some dry machines and stuff so that
somehow
you won't be relying only on the sun.
On the sun. Okay, but somehow I had loved the sun over decades. It's not easy for me, except for last weekend, where the rain poured and poured and poured, and somewhat emotionally, they say it's the weather for two.
Well, as always,
it's the weather for four.
As always, everything is so good.
What are we looking at today?
Part 2 of Aviation Fuel.
Okay.
Part 2. We are going to, it's a long one, about 9 clips. We are going to be
But before then, can you take 2 minutes, just give us a rundown of what we did before for our guests who may be joining, our viewers who may be joining us just for today?
Are you talking about
what we did last week? Just a brief rundown, just in a minute or two.
Oh, well, I mean, it's been talking about the aviation fuel part 1, and we talked about the different types of the aviation. We talked about Jet A1, Jet B, the avgas, and those cosmetic ones that are produced in the laboratory, and then the different types of airplane that that use them. So and of course anybody who wants to take a look and get comprehensive information, what you want to do right now is get to www.aviationfreaks, as in FREAKS.com. That's it on the screen for you. Get hold of that, or simply go to the platform of YouTube and type in the name Goddy Ike, Goddy, then Ike, not as one word, as 2 words, Goddy Ike, and then you see all my works lined up. Stay counting, close to 90 30-minute each videos, all on aviation. So go take a look and then educate yourself. There's so much to learn. And so, Atta.
Okay, we can hit the ground running very quickly.
Are we on ground?
We're on ground. Can we get clip 1?
In the air.
Okay. Let's hope we're cruising well.
Right.
Okay, can we have clip 1 very quickly?
Clip 1.
Okay, that's clip 1.
That's it. Categories of aviation fuel production. Aviation fuel is usually produced to meet the standards required by two main categories of engines. Fuel suitable for turbine engines and the one suitable for internal combustion engines. You can see when you talk about turbine engines, you're talking about those jet engines that suck in air, compress them, and then push them out through the exhaust to give you a thrust by the principle of action and reaction equal and opposite, which is Newton's law. And those are the ones, just like your piston, your normal piston engine of your car, but would drive propellers that are usually adjusted to have pitch that would bite through the air and produce forward thrust for you. And so those are the two main types of aircraft engines that are known to the world. So each one is produced within specifications internationally specified and recommended. Jet fuel used in both turboprop and jet engines is produced to maintain a low viscosity. Listen to this, it's very important, and my viewers need to really get hold of this information. They say jet fuel used in both turboprop and jet engines is produced to maintain low viscosity at low temperature.
What does that mean?
Very well.
What does that mean? Some guys who do not go through physics and chemistry will be asking you.
Okay, the thickness. When you talk about viscosity, if you touch either palm oil or the engine oil of your car, you feel the thickness. Now
it's like it sticks a little.
That's right. Normally that thickness should be more at low temperature. When you get it out of the can. With which you bought it, it's really, and when it heats up,
it gets so light.
It gets so light. But that's here is the irony. Because of those thousands of additives put in the one used by the aviation fuel, rather than have viscosity, high viscosity, that thickness at low temperature, rather the aviation fuel is light at low temperature, but at high temperature, the viscosity increases.
How?
Oh yeah, that's that's the magic of it. Because of those over 2,000 additives put into it. The whole idea is the jet engine is blasting away at very high temperature. It generates a lot of. Don't forget, when you talk about jet engine, you're talking about a section that contains the sucking fan, and then you have the middle section that is the chamber, the burning chamber. So when air is sucked in and compressed and put into the burning chamber, that's where the aviation fuel is introduced, and then that air is set ablaze right within that chamber, and then there is gaseous expansion creating very high pressure that is now moved to further to the turbines that that drives them at very high speed through the exhaust. So by action and reaction, there's Newton's second law of motion. Action and reaction being equal and opposite, as this is driving backwards, the pod is heading forward. But because it's attached to the body of the airplane, it takes the airplane along.
That's true.
All right? So
it's like a balloon. When you release the air, it moves.
That's correct. When you blow the children's balloon and let go, that air leaving
force the balloon.
Pushes the balloon forward. It's exactly the same thing that they. But then you would notice especially when a jet plane is, especially the war jets, when they are tearing away, you see the volume of fire coming out from those exhausts. So it's really, really hot in there. Now, if the aviation fuel is not designed to increase its viscosity at high temperature, what happens is that those metallic parts with which the engine is made will rub against each other and the engine will knock. And
that's good.
Yeah, and so is the aviation fuel is produced with a lot of additives put in there in order to reverse the natural process of having viscosity, high viscosity at low temperature and low viscosity at high temperature. Rather, you have a reverse. So you have low viscosity at low temperature and high viscosity at high temperature. That's the special thing about the aviation fuel for you. So it's good for my viewers to learn this today.
Okay.
All right. And so we'll get on with this. So it is also configured to meet the limits of density and calorific value, burn cleanly, and remain chemically stable when heated to high temperature. Have you heard that?
Fine.
That's what the whole idea of the special nature of aviation fuel. Let's run to clip 2 very quickly, please. Right, we are continuing with categories of aviation production. Aviation gasoline, that's the one that's formerly known as avgas, or 100 LL, that is, LL means low lead. It's a highly refined form of fuel for aircraft. It is configured to the highest level of purity with anti-lock characteristics and minimization of spark plug fouling. The performance guidelines required of avgas includes the fact that it must be rich during takeoff and lean during cruise in order to reduce fuel consumption. Although avgas is usually sold to many more individual aircraft operators, its sales volume is much lower than that of jet fuel, which is usually sold in higher volume to large aircraft operators such as airlines and the military. All right, clip 3 very quickly, because we have 9 clips to run and time is never our friend on this program. Right, chemical composition of aviation fuels. Aviation fuels are blended with over 2,000 chemicals. I said that before.
That's true. Which
include hydrocarbons, such as paraffins, olefins, naphthenics, and aromatics. I mean, all these are derivatives of our crude, as a matter of fact. And that's why it's quite a shame that we are not doing enough to have our crude value added to our crude here before selling them by refining. And so that's where you get all this stuff. One of these days, God will help us get more serious and have things going on well. Now, other additives include antioxidants, metal deactivators, biocides, static reducers, icing inhibitors. I'm sure by the name of all these things I'm calling, you have an idea of what they are supposed to be doing. And corrosion inhibitors. Major components include N-heptane and isooctane. Well, they are all the same stuff that we've described before. Aviation fuel for spark-ignited piston engines are usually described by their octane rating. Clip 4, please. Here we go at international. You do believe it that you have tax politics going on?
This is moving around the world, and men will play around it.
Oh yes, oh yes. International tax politics concerning aviation fuels. Article 24 of the Convention on International Civil Aviation, fondly called the ICAO Chicago 1944, exempts aviation fuels already loaded on aircraft on landing and which remains on the aircraft from import taxes. That means, normally if you fly from Nigeria to, say, London, the aviation fuel inside the plane which you bought in Nigeria, it should be seen as imported product. And normally The government should be able to come and
how would they assess the amount of volume that's left?
You take a look at the panels. I mean, just like your car, you can as well ask, how does anybody know? And that of airplane is even more precise because it is digital. It tells you both the volume and the literage.
Not just the meter.
Not just the pin. Not just the pin being out somewhere. It tells you precisely the volume that you've got there, either in pounds or in liters, or both. So it's there for you to see. The inspectors can just walk in and say, okay, you have 1,000, just for an example, you have about 5,000 liters of fuel on board. And so this is what so much here in Great Britain, and your tax is so much percentage, and we expect you to pay so much. So how are you paying? You have your debit or credit card, or there are a lot of payment options, and then they tax you and you pay. But Article 24 haven't considered thoroughly the importance of allowing airlines to move from one country to the other without this stress. It's saying those fuels should be exempted from taxes, but a lot of countries don't agree. As you will see as you read on.
It's gone.
Yes. Bilateral Air Services Agreement, BASA, governing the tax exemptions of aviation fuels. That is bilateral Air Services Agreement govern. That's what governs the tax exemptions of aviation fuels. Around the world, however, many of these agreements have been modified to allow taxation of onboard imported aviation fuels. Can you hear that, Atta?
Yeah.
Although a number of countries favor taxation of aviation fuels, United States of America and Australia are vehemently against taxation. According to United Kingdom Parliament, tax income lost to aviation fuel annually is estimated at about £10 billion. Can you see what Great Britain is already, grumbling about? That about £10 billion is lost, to tax exemption, when all the airplanes coming from all over the world.
But they make tax from landing, they tax several other areas.
Any way to make more money is as good as can be, as far as they are concerned. We should actually do more here. For instance, I see people running red lights, and every day I see hundreds of thousands of naira lost, that money that government could easily make, and in the process get us to be better people. But I sit on the traffic light and I find cars on my left and on my right running the red lights, and nobody is checking anyone, and is turning us into a bunch of irresponsible ones.
Sometimes you got two policemen there across who just want to collect their own.
But we should actually make money from those illegalities.
Let's move on now.
Yeah, clip 5. Clip 5.
Clip 5 quickly.
International Aviation Fuel Certification. Aircraft are usually aviation fuel. Let me explain something here. As a matter of fact, one of my followers had called to ask me, why do you always say aircraft are? Why not aircrafts are? And I need to explain to those who do not know. The word aircraft is what is known in English language as uncountable noun. Okay. Yes, that it's one of the group of words known as uncountable noun, which you cannot add s to. So aircraft is aircraft, one aircraft, two aircraft, 1,000 aircraft. You can't say two aircrafts. That is wrong English. And so let's move on. I'm doing this because I had somebody call me to ask questions. I had me.
What are you addressing in the plural?
Yes, he had me severally, mentioning, more than one aircraft, and then I continued to say aircraft, and he was wondering, is he still Godike that's speaking this kind of English?
Okay, we've got that now.
All right. So that's an uncountable noun. So aircraft are usually aviation fuel type certificated. Fuels, therefore, have to conform to a specification in order to be approved for use in airplanes. The American Society for Testing and Materials, ASTM, develops specifications for both automobile and aviation fuels. ASTM D910 and ASTM D6227 for aviation fuels. That's the categorization for those. And then why ASTM D439 or ASTM D4814 are for automobiles. So that is the certification. And then if you, the photo you're looking at there, those are holding tanks for aviation fuel. The sort of thing you find in Kaduna, the tank farms. That's correct. But those are very special ones made purely for aviation fuels. All right. So clip 6, very quickly. Time is running out now. Methods of distribution of aviation fuel.
We talked about that briefly at the introduction.
That's correct. In America, Europe, and other developed countries, aviation fuel is usually distributed via pipeline systems. It is pumped over and dispensed from a tanker or bowser, which is usually driven up to packed aircraft and helicopters. In some airports, filling station-like pumps are installed and airplanes taxi up to them and get refueled. In some other airports, permanent pipings are made to parking areas for large aircraft. You can see that photograph there. You see that vehicle there is on the pump.
Like a manhole.
That's correct.
Taking fuel through the vehicle is just like a pumping machine.
That's correct. That's all that you can say is.
But why can't we get that here?
Well, my dear,
because when Hadi Sirika was remodeling the runway, who would have added this to the contract from
the
piping process?
Yeah, that's a problem with that. If you haven't done a piping all the way, say, from the nearest tank farm in Kaduna.
But you can have a small fuel depot close to the airport.
That's very possible. But then again, you have to contend with higher hazards if those kind of depots are close to residential areas. And of course, you know that the airport is already surrounded by residential houses.
But not Abuja. Abuja got enough empty now, but Lagos is already
all right.
fully choked.
Yeah. But these are things that needed to be planned from inception when we were dotting these airports around the nation. We should have had comprehensive plan.
Why we are remodeling? We would have remodeled and remodel this one.
Well, maybe those who were involved in the planning were not thinking in that direction. Not necessarily cost. Sometimes, if you don't think things through and you don't invite knowledgeable ones to sell ideas, likelihood is that you're going to do things and then soon find out. For instance, in Abuja, can you find any public toilet where anyone can just walk in on the ground, like you find all over the places in civilized countries, especially in London, where if you're pressed, you get to the nearest on the ground toilet facilities and ease yourself. But over here, you find dignity of men and women being reduced. When they are pressed, they stand by the side of the road and do their thing, and that is absolutely unacceptable. But the planners of Abuja just didn't seem to remember that date. So that's where we are. Are we done with clip 6, or we're just about to start there?
I think we're done with clip 6.
Yes, we're done with clip 6. Let's move to 7 very quickly. Here we go, Atta. One of two methods is usually used to transfer aviation fuel to an aircraft: over-wing or on-the-wing fueling. That will make you recall the photograph you saw in clip 6. When you do an on-the-wing kind of fueling, it's under pressure. Those things must be pushed under high pressure.
And screwed properly.
That's right, and those happen in most big aircraft. But for the lighter ones and helicopters, you do an over, above, just like dispensing in your car, then that does not require pressure.
Okay.
That's the difference between the over wing and on the wing,
right.
just for our viewers to understand what we're talking about. So over wing, this is used on smaller planes, helicopters, and all piston engine aircraft. It is similar to car fueling, which does not need pressure. You get that? But on the wing, known also as single point refueling or pressure refueling, on-the-wing fueling is used on larger aircraft and for jet fuel exclusively. Clip 8, please. Precautions against misfueling. Clip 8. In order to avoid the danger of confusing, this is very important, and you see, you know, the tricky nature of, refueling airplanes. In order to avoid the danger of confusing fuel types, precautions are taken to distinguish between avgas and jet fuel. Apart from clearly marking all containers, vehicles, and piping, the aperture on fuel tanks of aircraft requiring avgas is usually not greater than 60 millimeters in diameter, and the dispensing nozzles between 40 and 49, 49 for US only. But otherwise, every other part of the world is usually 40 millimeter aperture for the dispensing nozzles. Okay? Avgas is dyed as a means of clearly distinguishing it from the straw-colored jet fuel. Jet fuel is dispensed from a special nozzle called J-spout, okay, or duckbill, which has a rectangular opening larger than, you see what the whole idea is, so that if you pick up a nozzle that is supposed to be for jet fuel and want to use it on a plane that uses, avgas,
it won't fit in.
It won't fit in. And immediately, you know that you're making a mistake. You're about to put in wrong product inside. That can cause an accident because those engines will stall. All right. Okay. So, say a rectangular opening larger than 60 millimeters diagonally, making it impossible to fit into, avgas pores. Final clip quickly is safety precautions in clip 9.
Clip 9.
All fueling operations are usually dangerous.
All?
Yes, usually very dangerous. Just like sitting in the airplane and working on the engine like one of the airlines did at the time I caused their flight to be aborted. Before eventually it crashed 2 years after for the same reason that I said to them that night, don't fly. And special characteristics of aviation operations must be accommodated. Airplanes accumulate static, listen to this, very important. Airplanes accumulate static electricity as they fly through the air. You remember what static electricity is? Do you remember, especially during the Harmattan period, you touch your door handle and you get a spark, pop, right? That is static electricity. So airplanes build them up as they tear through the air. So if this is not dissipated before refueling, an electric arc could occur and ignite fuel vapors. And that will, of course, explode into huge inferno. Okay? Now, excuse me. To prevent this, therefore, airplanes are electrically bonded to the fueling equipment before fueling commences. If you've noticed one of the fuel tanks coming to refuel the airplane, which they do once in a while people are already on board, they actually are not supposed to be doing it while you're on board. The airplane should be really refueled before getting on board, but sometimes these things are breached. If you notice, you'll see that there's a long red wire that they connect to the body of the airplane, and then that's not the wire supplying the fuel. Before the hose is fitted from under the wing, that is the electrical bonding that is preventing those static electricity from sparking. Okay. Otherwise, if you let them
let's run quickly, our time is up.
Yeah, that's right. So I stopped it. In some regions, the airplane or fuel truck is required to be electrically grounded. All right? A dead man's switch, that is the name of this switch, and I'm going to explain it later on if I find time. A dead man's switch is usually incorporated to prevent unmonitored operation. Furthermore, all fueling vehicles must carry fuel speed control equipment. Fire extinguishers must be present at any fueling operation. Contaminants such as water and dirt must be checked on daily basis. Atta, did you hear that? On daily basis. I hope we do so here. And before every flight, should passengers be on board during refueling? Did you hear that? Should
I have been on board during refueling.
Very well.
I've been on board during refueling.
Seat belts are required to be unfastened. All right. So that is the safety precaution for fuel. And by this, we are done with everything my beautiful viewers need to know about aviation fuel. And I hope the gentleman that called from Texas and cost me to do work on this would have gotten all the information that he needs. Get on YouTube and you'll find this program and you get everything you need. And of course, continue to enjoy this program and enjoy your flights all over the world.
Thank you very much.
Yeah.
Thank you very much.
It's my pleasure.
Wish you all the very best.
Next week.
Are we keeping it secret or you announcing it?
Sorry?
Are we keeping it secret or you announcing it?
No, I am thinking that with this advent of Nigeria Air that will take off in December, we should run through the rise and fall of Nigeria Airways.
Okay, we'll do that once again. You know, sometimes, like in the music world, they'll say once music is nice, you play twice. We'll look at Nigerian Airways so that this time around we will not make the mistake. I know many guys are on the social media trying to at least somewhat attack Air Nigeria, but let's give them time and watch how far they take off. Okay, quickly, we'll take a break. When we return from the break, my colleague Gabriel Kuma will be on set here. We'll look at JAM. Yesterday we got the shocker again, the second shocker, that JAM remitted over 7 billion naira. And many are just asking questions, just ordinary JAM and all of that here. But over the years, decades, JAM never remitted even up to 300 million naira. How this magic and all of that, Gabriel Kuma and Ebenezer Oyetakin will be discussing that after this break.